Hi, it's Alex Williams of the New Stack here in Shanghai, China for KubeCon plus CloudNativeCon Open Source Summit China 2019. And today I am here to talk with Xiao, engineering lead, Tencent AI Lab. How are you?
Yeah, I'm good. How are you?
Yeah, it's great to have you here. I really appreciate you participating with us. One of the questions I have, and I'm really curious, but we hear a lot about AI and we hear a lot about ML. But it doesn't just come out of nowhere. It has its roots.
Yes.
What are the roots for you in learning about AI and ML? When did you start studying it? And maybe you can then, because I'd like to use that as a jumping off point for providing some context for your work today.
Yes. So actually, I mean, people talk about AI today, and they think this is like a booming new topic. But actually, it has a very long history. I mean, before that, we call it machine learning or pattern recognition. So I studied machine learning since I was a bachelor student in Beijing. So it has been like 10 or 12 years already. And so the recent advance of like all the computational power, like GPU, CPU, and all the edge device cloud service, they actually boost the development of artificial intelligence. So it makes the research of artificial intelligence faster and faster. So this actually put AI back to the stage of on the spotlight. Because previously we have some theoretical ideas that stay on the paper because of the computation, because of the huge computational demanding, right? So we cannot even implement that in practice. But now those things that previously we can only imagine now becomes reality, right? We can train a super big image classifier that can recognize thousands, hundreds of thousands of objects. This is actually doable now, right?
Mm-hmm.
So, yes.
So your earliest research, what were you doing?
In my early days, I was doing some natural language processing, and in particular, I focused on using Bayesian method to try to analyze the data, doing some language model. So this was during my master study, and in my PhD, I was doing some like max margin, the support vector machine, kernel machine, and then moved slowly to the deep learning. But interestingly, I got my PhD in 2014, and so that year was actually, there is a paradigm shift from the traditional, what we call nowadays called shallow learning, to the deep learning. So, yes.
What was shallow learning?
Shallow learning is what we call the methods that do not use deep neural network. So there are families of machine learning methods or machine learning algorithms that do not rely on deep neural network. They rely on some mathematical optimization theory. So these are those methods were very, very popular back in, let's say, before 2010. And after that, there is a paradigm shift, slowly move towards deep learning or deep neural networks. Yeah.
I worked with a company in the mid-late to 1990s that had developed a way to take neural nets and then apply multivariate analysis
Yes.
to the neural net technology for food science purposes.
Yes.
Is that evolution? What was the evolution? You know, that seems like that's an older form of that would seem to be more the shallow learning.
Yeah,
right,
exactly.
And the deep learning would be what then exactly? It's the neural net plus what?
It's basically trying to, instead of using mathematical formula to represent the underlying truth of the data or underlying pattern of the data, we now ignore the mathematical formula. We try to use some nonlinear combination of the neurons and try to approximate the underlying representation or the underlying distribution of the data. So what the distribution really looks like, it doesn't matter, as long as we can approximate using a lot of thousands, hundreds of thousands of neurons to approximate that. So this is a different kind of methodology where we feed a lot of data to the model and let the model to figure out the correct representation of the data or the correct distribution of the data.
Which required a different underlying resource, didn't it? A different kind of architecture underneath it, didn't it?
Yes, it also requires a completely different set of, let's say, skill set. Because previously you need a lot of mathematical background as a cornerstone in order to to figure out what's the correct mathematical form of the distribution, right? But nowadays, you just need to feed a lot of data. But then it comes to the problem like scalability. How do you feed the data fast enough, right? How do you train the model fast enough in order to get the correct representation? So you see that after the paradigm shift to the deep learning, the AI becomes more like an engineering problem rather than a research problem. Yeah.
And as an engineering problem, then you would find, I expect, the challenges of having the right compute network and storage, isn't it? Would that be accurate? You need that. You're talking about to be able to feed the data in.
Yeah.
You need to be able to have the data store there very quickly.
Yes, exactly.
The network may not be as critical, but the data store is critical, isn't it?
Yes.
And then you need the compute power as well.
Yes, exactly.
Right?
Yeah.
But you do need the networking kind of architecture to be able to bring those things together.
Yes, but that's, I would say, in the advanced level. On the basic level, usually people like a lot of AI researchers, they have a machine learning background. They don't have, of course, they are computer scientists first, right? But what they really focus more is about the algorithm itself. It's not about the engineering, like the database, the distributed system, or the distributed topology behind that. So usually, so basically at the Tencent AI Lab, most of the work, most of the data are loaded directly from the local disk, let's say, or they are not relying on highly distributed storage. But of course, there are certain like AI infrastructure which has high demands, like image classification, face recognition, speech recognition. The training data of those models, they are actually distributed in the network, right? So, yes.
So when you completed your PhD in 2014, you talked about that paradigm shift.
Yeah.
And where engineering became more important than the mathematics itself, right? And so tell me about that time and what that has and where we are now. So, 2019, like what were the tools like then? What were the engineering practices like then, and how have they evolved in those past 5 years?
Yeah, so this is a very interesting question. I try to make a summary of this kind of paradigm shifts. Basically, if you talk about AI innovation, right, there are two types of innovation, in my personal perspective. One is from 0 to 1 innovation, means that if we put that into AI context, it means hardcore research, basic research, like proposing new learning paradigms. This belongs to the 0 to 1 innovation. And the other line of contribution is 1 to N innovation. So this focuses more on the reusability, scalability, like solving the problem that how can I adapt this AI algorithm from one domain to multiple domains, or how can I scale this AI algorithm in order to serve billions of customers? Solving this kind of problem belongs to 1 to N innovation. I believe these two lines of innovations are equally important, but I mean, if we look at China, right, all these big internet tech giants in China, their AI innovation more fall into the 1 to N innovation. And a lot of people, after the paradigm shift, a lot of people, researchers, engineers, they're moving away from the 0 to 1 innovation and start working on the 1 to N innovation. The reason behind that, because before the paradigm shift, there is still a lot of debate, argument, discussion about what is the best algorithm to implement artificial intelligence. What is the best way to realize artificial intelligence? And now people start to, when we stand here in 2019, I think it is safe to say that deep neural networks or deep learning is the de facto solution of artificial intelligence, at least from now what we see from here. So a lot of people stop discussing on which is the best way to implement AI. They start to think about, okay, now that deep learning is the way to implement AI, how can I make it sense? How can I make sense of it? Right? Yeah. How can I adapt my domain knowledge into the model? How can I make it more usable, more scalable, more reliable? So that's why this paradigm shift actually boosts the population moving away from the 0 to 1 innovation to the 1 to N innovation.
So with that, how have the tools evolved? How have the practices evolved in these past 5 years? How have the workflows evolved?
I think there is a huge competition on the, let's say, the deep learning framework level, right? So, like back in 2015, if you ask a question like, what is the best, what is the tooling that you are using for deep learning, right? There are tons of questions like deep learning for J, Intel mass kernel library. Some people even use MATLAB to do the deep neural network. And if you ask the same question again today, I think there will be only 3 answers: TensorFlow from Google, PyTorch from Facebook, and the others. Right, and of course these 3 communities don't like each other. Right, so you see that the framework level, on the framework layer, the competition is already like accomplished, it's done. So for other companies, it's very hard to propose a new deep learning framework into this market, because this is already a red ocean. The competition is finished. So all the customers, they belong to this either 3 of these communities. Yeah.
So where does Tencent fit there?
Yeah, Tencent actually also has its own deep learning library. It's called NCNN, but it is optimized for computer vision and face recognition. So it's a pretty low-level network. It's based on C. And also Baidu has its own deep learning network. It's probably more famous than Tencent one. It's called Paddle. They take a lot of ideas or inspiration from TensorFlow, but eventually they make a very unique and very high-performance deep learning network. I believe Alibaba also has its own network, deep learning framework, but it's not as famous as TensorFlow or PyTorch or Paddle. Yeah.
So what's your research based on now?
I'm currently working on neural information retrieval. So the idea is to, basically the idea is very simple: searching similar content from the database. I mean semantically similar. It could be like searching semantically similar sentences, or it could be searching semantically similar images, or even searching semantically similar videos, short videos. Of course, the backbone or the cornerstone of the whole framework is actually based on deep neural networks. Yeah. So this is actually my work at Tencent AI Lab.
So let's talk about use cases that you're seeing.
Yeah.
How have the use cases evolved in the past 5 years? What are the use cases that today that are different than those from 5 years ago?
I think when we start this project, the use case, the main motivation of doing this project is to serve the smart speaker. All right, you know that in the last 5 years, there are a lot of smart speakers, like from, for example, Apple Siri is also kind of a smart speaker. Amazon Alexa, Google Home, all of these big tech giants has their own smart speakers. But the basic, if you analyze the basic user journey behind that, they all follow the same kind of journey. Basically, first the user has kind of intention, so he wants to speak to the smart speaker, and the user speaks, and the speaker receives the commands and try to analyze the command. After that, the speaker gives a response to the user. Right? So if you analyze the process, you found that receiving the commands, this basically requires a speech recognition module. Right? This is not what I'm focused on. But then analyzing the commands, like comparing to the commands that users speak out to the commands that we supported from our database. So there is kind of like a fuzzy matching in between. This kind of fuzzy matching procedure is what we call neural information retrieval. Right?
Okay, so it's that fuzzy meshing.
Yes, exactly.
And then it has its roots in what you were talking about, this understanding the semantics.
Yeah.
It might be of a sentence, it might be of a picture,
yes,
it might be of a
short video.
A short video.
A short video is a very recent use case. This doesn't exist like 2 years ago. Just because of all these short video apps start to emerging, like TikTok. You probably heard of this. This is from Chinese company called ByteDance. TikTok is a super popular like short video apps. I mean, Instagram also has its own short video.
Yeah.
And yes, so that's basically the current. But current two applications that I know. At Tencent, we also have our own short video apps. I don't know the English name of it, but we're trying to make it more popular. So we're trying to do some recommendation based on the content of the short video. And of course, if you want to analyze the content and find the similar content that close to the short video that you are currently looking at, this requires some kind of fuzzy matching again. But you know, there is after a certain level of abstraction, you will realize all of this doesn't matter the content form that you are handling with. Right? It doesn't matter whether it's text, it's video, or it's sounds, or it's images. You need some kind of unique representation underneath the data in order to capture the semantics of the data. Right? Yeah. So that's the basic motivation of doing neural information retrieval.
So how are the architectures changing that, we see it, at the new stack, we cover a lot of ways that at-scale development, deployment, and management of application architectures.
Yeah.
How do you see the intersection of those, of at-scale application architectures with AI and ML? How do you see that intersection happening?
Yeah, I think there is also like a paradigm shift again in terms of AI application. So most of people think about AI, they think about a pipeline that is just a single app, a monolith app, right? But nowadays, what we're trying to develop in my group, in my team, is we're trying to develop a cloud-native app. Right. This basically means that decoupling all the components, decoupling all the algorithm from the pipeline as a very democratic microservices group, right? And trying to communicate with each other using some consistent version API, right? And so this is something that requires a lot of engineering work that probably most of the AI scientists or engineers that currently they don't have. So there is still a learning curve for them, actually.
Mm. Yeah, we're seeing that with, for instance, in the data science community, right?
Yes.
Where like they have been working on their laptops or their desktops.
Yes.
And now they are thinking, now as application architectures are increasingly distributed,
yes,
that now we have to think differently about how these practices are applied to the application architecture.
Yes, exactly.
What are some of the findings? What are some of the learnings that you've had that speak to this movement?
One of the most significant finding I found from my German company, German employer I worked before, and also at Tencent, is that people like data scientists usually hate this movement because this movement actually slowed down their exploration process, right? Because this movement basically suggests that, okay, so whenever you have an algorithm, you have to put that into a microservice, and this microservice has to be wrapped in a container. This is a mutable container, so you cannot change this as you wish. And then you have to deploy this, all the kind of stuff. So this basically slows down the exploration of the algorithm. So this is what usually the data scientists hate most, because they try to, every time they try to tune a parameter, change a layer in the neural network, they have to change the code base. And they have to deploy all this stuff again. I mean, if they are not doing the engineering very well, right? So they have to do repeat the whole procedure again. This is currently the findings that I've found most of the data scientists actually don't like to follow these steps. Yes.
They're finding the pains that developers have faced for a long time.
Yes.
Yeah.
Yeah, but of course this needs a lot of like a best practice learning and also
right.
Yeah.
Right.
Yeah.
So we're just at the beginning of that learning curve.
Yes.
So would you say that paradigm shift is 2019 for that space, or are we still waiting for that paradigm shift to happen?
I think in a lot of tech giants like Google, Facebook, they are of course already in the pretty mature phase of this paradigm shift. A lot of AI engineers or AI scientists already has this kind of skill set. They know what is cloud native, and they know the necessity of, let's say, starting cloud native from the day one. Right, there is no like a handover, so the data scientists do the fancy things and then hand over this to the engineers, and then engineers try to optimize. I believe at Tencent we also have some tech groups that already
Hi, hey Alejandro.
How are you?
Good. How are you? We were just I know you have to leave around
Yes,
4 in a few minutes.
Yes, exactly.
But we were going to talk about Kubernetes with Alejandro here. And so maybe just the last, before you have to go, and because we're talking about paradigm shifts and kind of AI and ML. And I'm curious on, you do hear, when you hear cloud native, you do hear about Kubernetes, obviously.
Yes.
I know you haven't really put a lot of research and thought into this, but any kind of, you talk about the data scientists and their kind of like the learning curve.
Yeah.
What's the learning curve then for you at this point? What are you trying to learn about Kubernetes and kind of the whole container architecture, cloud native?
Actually, I learned this like 3 or 4 years ago when I work at a German company. And so what we currently using is actually the Docker swarm. That I feel a little bit ashamed to say that because this is KubeCon, right?
That's all right.
But still, like we are trying to, we're actually trying to make the decision of the orchestration by the users, not by us. So we're trying to separate this kind of decision from our overall architecture. That means the user can decide to use Kubernetes, they can use Docker Swarm, or they can use our built-in orchestration for the Cloud Native app. Yeah. So this is actually, for the Kubernetes, I don't know so much about that, to be honest. But I think it's a great chance. I see a lot of people coming here, and it's a strong indicator that I have to learn this. Yes.
Well, I think we're all on that journey, aren't we? So, Han, thank you so much. I know you have to get somewhere in a few minutes, but I'm joined now with Alejandro Saucedo, the Chief Scientist with the Institute for Ethical AI and Machine Learning. Han, thank you so much, and I look forward to following up and having another chat.
All right, thank you. And
all right. Well, Han has to get somewhere. I think there's actually a press event that he's going to, and Alejandro, I wanted to talk with you a little bit about the path to AI and machine learning from your perspective. One of the things Han was talking about is like the journey of the data scientist, right? And how that, and the roots of AI and ML, and how there was a paradigm shift in 2014, and now in 2019, we're looking at a number of different frameworks that are available, but in the meantime, cloud native architectures have also been going through this, have seen this rise in popularity. Where do you see yourself? Where do you see your research, right? And how do you see that intersection between data science and application architecture development?
Yeah, that's an excellent question. I think that the reason why we're now seeing such a shift is not just because we're thinking about platforms like Kubernetes. I think it's more because it's a purely concept shift. And this is primarily because we're now seeing the intersection of data scientists with other professions like sysadmins, like DevOps, but I think more importantly with domain experts. People that would normally be the ones that would know an industry in and out, or even potentially the regulations, limitations, or ethical frameworks that need to be in place. Now that is a concern for the frameworks that are released, the models that are built. So the challenge here is that now we're trying to standardize the way that machine learning really operates, and the research that we do is primarily focused on standardizing these concepts, going from a higher level framework all the way to the ethical frameworks, and then trying to break it down into standards, into processes, into best practices. So it's the whole spectrum.
What are the ethical frameworks?
Mm-hmm. That's a very interesting one. So one of the ethical frameworks that we contributed to was the ethics guidelines for trustworthy AI that the European Commission released recently. Those are a prime example of some of the things that currently a lot of governmental bodies are trying to look to be able to make sense and provide some sort of higher level taxonomy and some sort of agreement on the definitions of some of the terminology, right? An example could be the difference between interpretability and explainability. And that fits a lot in regulation that is now in place, even before that was set up, like GDPR, right? So not only we see some of those incoming frameworks, but we see companies also setting up their own internal, they call it normally principles, right? Our principles for the use of AI, principles for AI for good, et cetera, et cetera. So we're seeing this not only on a national level, but we're also seeing it on a company level, and we want to see it in a more internationalized or globalized manner, where we have some sort of overarching agreed set of standards that we abide by, similar to the ones that we had set up for space technology back here.
The European point of view is interesting, isn't it? Because it does speak to the heritage of the European community in looking for that balance between technology, privacy, and ethical responsibility. What do you see as the roots of that in AI and ML? Going forward, and I mean it's a very different approach, and one way you can attribute it to is the European history and its understanding of what happens when there's too much power consolidated in one place, and there seems to be an analogy there with AI and ML and the European point of view.
Yeah, that's a hard question, both conceptually and practically. Primarily because if you think about it, privacy as a high-level concept has not shifted significantly. It still fundamentally demands the same thing. The difference is that as technology advances, as new methods to exploit the use of, in this case, data, we have a shifting perception of then the dangers of people having those tools, right? So an example would be with a data set that perhaps may not have changed in the last decade, but because the technology itself has changed, the amount of insights that same data set provides are much larger. So then without changing the assets, you increase risk as technology advances. And the reason why it's we're living in a time where privacy and all of those terms are so important is because with this massively breakneck speed in which technology is shifting, we can't cope with that societal understanding of how technology fits in. Right, and another example is for example, telephones. Right, we know that telephone itself, the lines are going to be to some level tapped on to make sure that the national interest of security is aligned. Right, like there's no terrorist attacks, etc., etc. But at the same time, there is an acceptance in that in the standardized way that people and governments are able to track and manage that. Right, with new platforms like social media, we don't have that yet. We don't know what level of government intervention, corporate intervention should be in place to be able to have that security, but at the same time privacy, right? So it is a shifting battle between what we should have in order to be able to enforce the level of standardization that society requires, but at the same time to make sure that we respect people's privacy. So it is a very, very hard, challenging topic that we need to really sit down with the right experts to discuss.
It really is a time of chaos in many ways in terms of kind of the types of technologies and the ramifications. Let's shift the conversation a little bit to Kubernetes. And I was interested in that as a topic because I know that you have invested time and resources into thinking about Kubernetes from an ML AI point of view. Can you tell me a little bit about why you started looking at Kubernetes? What was it about it? Why did you need to think about cloud-native architectures? Because they're very much application-oriented and not, oriented around consensus algorithms, as Han was just kind of talking about.
Yeah, that is an excellent question. And I think the reason why Kubernetes is such a big player in this case, I basically are currently running, plus the institute, an engineering department at this open source infrastructure for machine learning library. And we use Kubernetes as a backend, primarily because when you talk about Kubernetes, you talk about scale. You talk about not one data scientist being able to track their experiments, but 300 or 1,000 data scientists dealing with multiple models, with multiple data sets, requiring that level of standardization that if it's not in place, it just becomes chaos. So once you have companies that have this large amount of use of machine learning, you have to introduce those processes that allow for alignment in compliance, in regulations, and with the scale in which data is being managed, there is a lot that needs to be done programmatically. With Kubernetes, you're able to abstract these very complex infrastructural issues into, as a programmer would see it, an object-oriented problem. You can create blueprints of what would be the different pieces of your infrastructure and then instantiate those in encapsulated scopes. So even though you may not know the exact granularity of everything, you are able to abstract those layers so that you can have the right experts looking at those. So Kubernetes, especially with the custom resource definitions that are relatively recent, 2 years more or less, that has really introduced a new concept that has been able to bring to the table the system administrators, the site reliability engineers, the data scientists, and the domain experts, people that are operating these technologies in production, to make decisions not only about the technology, but also at the use of this technology at scale.
Right. So custom resource definitions, and for those who aren't as familiar with them, perhaps you could help explain them a little bit, because they involve kind of there's a few different elements to them.
Mm-hmm. Yeah, so custom resource definitions are an ability to be able to delegate the responsibility of specific operators that you would have others otherwise have to manage centrally. So now what you can do is you can, for example, in our case, define a machine learning deployment as an instance that may have specific qualities. In our case, it has an inference graph, it has a specific set of endpoints, it has a specific set of metrics. And then you're able to instantiate multiple objects, multiple instances of that custom resource definition that would then be running in production. You would be able to manage those resources, see how they're performing, see their health, et cetera, et cetera. So it is a level of abstraction that allows you to encapsulate your infrastructure into human understandable chunks.
Mm-hmm. And so that allows then for those operators almost to be like Kubernetes architectures within themselves, aren't they?
Exactly, and that allows for very powerful sort of alignment on conversations, because now you can introduce things like design patterns. One of the design patterns that we are introducing is the concept of deployment of a model, a machine learning model, a black box model, and then its respective explainer. So you would have one model performing inference, and then another model explaining why that one provided the prediction it did, right? So you can have this level of abstraction that can allow you to think on a much higher conceptual level.
Interesting. So what are some of the use cases that you see evolving?
Yeah, so I would say that right now the use cases are quite agnostic. Like, they apply in every industry, in back office, in front office, in every single department. I was recently in an HR conference, discussing both the applications and the ethical considerations. I think the challenge is not as much anymore what the applications are, but it's about how to get out of what we call POC land, proof of concept land, right? It's startups coming in and just doing a proof of concept over here, a trial over there, a prototype over here, because the jump from going, from a demo, from a prototype, into an enterprise-ready, scalable solution that is compliant, that aligns with policies, that is able to align with internal risk assessment processes. That is something that we are still in the journey to understanding how machine learning fits in. So I think the use cases piece, I've seen automation of lawyers through NLP, automation of revenue, metric generation, et cetera, et cetera. I think use cases, there are plenty, and that's one of the things that we see often. The question is, how can we convert those?
So we're running a little bit out of time. So how would you see going forward converting those? What are some of the practices that you see evolving, and how does Kubernetes and cloud native architectures fit into that?
Yeah, so I think this requires both a high level standardization of the taxonomy, the processes, the best practices, but also there is a need for answering the question of what is the infrastructure that needs to be in place in order to make sure that reality matches expectations. Because we can sit here, have our own definitions of principles, of ethical frameworks, but if we cannot have the right infrastructure to monitor, to raise issues, to be able to provide metrics, we're never going to be able to say, okay, we align with the policy that we introduced. So what we need to have is that intersection between the work that the Cloud Native Foundation, the Linux Foundation, all of those organizations are doing with the open source frameworks, and be able to have some sort of match between these are the standards for algorithmic bias, for transparency, and these are the tools that you can use for each of those. So I think it's basically, we know the techniques, we know the tools, we're working on the standards. We now need to have the right people and the right touch points to make those processes that fit both worlds.
So the Kubernetes architecture underneath allows for a greater capability for data scientists then as well, because now it makes them just much more democratic, if without kind of thinking of any other kind of word to describe it.
Yeah, I think an example, because I think that got a bit abstract, but an example that I can give is how Kubeflow, this machine learning training platform on Kubernetes that we're contributing into, this platform is currently working into creating a set of standard metrics for machine learning models in production. And this is basically asking the question of, if you put a model in production, what should be the minimum metrics that you should be obtaining from that? We know that with microservices, it's going to be latency, uptime, et cetera, It's the same question. Is it going to be accuracy, precision, recall, model divergence, et cetera, So it's trying to standardize those things, because once we have those metrics, then we can start aligning them to then questions of, well, how much human in the loop should we have? How much, what domain experts should be reviewing these pieces? Those kind of things.
So I know we're running out of time, but Kubeflow, why did you choose Kubeflow?
So I think that was more of a strategic decision from Selden. We were able to sit down and see one of the biggest cross tech company collaborations that we've seen within machine learning and Kubernetes. Having Google, Red Hat, Bloomberg, and even some companies here in China interested and contributing to some of those areas. It was too powerful for us not to actually come in. And Selden being such a key part in the deployment side, it was just quite organic. So that is primarily the reason. And I think looking back, it has been so far, at least advancing the conversations, definitely a good choice.
Selden?
Selden Technologies, yes.
And Selden is?
Selden Technologies is a machine learning serving platform. So once you get to a model that is built, that's where it starts. Serving the model, providing the metrics, et cetera, et cetera.
Great. Well, Alejandro, thank you so much for taking some time to talk with us. I'm glad we were able to have this conversation. It's been really enlightening, so thank you for your time.
Thank you. Thank you very much. Really appreciate it. Thank you.